So today I want to introduce you to the new product isoHR685 W-D or a sensor variant -S, -I, -B. And the presentation has a content like this. First, I want to give you some general characteristics of the new isoHR. Then we want to talk about the special characteristics. A short summary, what is the market of the product, what are typical applications, and we want to have a small look to the competitors. Just one moment. Okay, so let's have a look to the general characteristics. With the isoHR, we can monitor systems up to 1000 volt AC and up to 1300 volt DC, plus minus 15% without an external coupling device. Up to 1000 volt, we can monitor systems with overvoltage category 3, and bigger than 1000 volt, we have to reduce the overvoltage category to 2. We have two different response values between 10 k ohm and 3 gigaohm. The response time is like at the normal iso685 variants, depending on the profiles. We have the same profiles included, but just the profile, power circuits, and high capacitance works up to 10 gigaohm. We have automatic adaptation to capacitances up to 1000 microfarad. I think you know this from the standard devices. We have the same high resolution display to visualize the values and settings like the other variants, and we have also the measurement of the voltage, the frequency of the system, and the capacitance. The voltage and frequency measurement just works for 690 volt AC or up to 690 volt AC and up to 1000 volt DC. So if you have applications for 1000 volt AC or 1300 volt DC, the voltage measurement and frequency measurement doesn't work. The accuracy of the product looks like this curve. So here the horizontal line, you see the 15%. We have to specify according to the product standard 61557-8. And we see that above 200 mega ohm we are above the 15%, and down to 10 k ohm or below 10 k ohm we also have above operating uncertainty above 15%. It's clearly depending on the capacitance, the system leakage capacitance you have inside the system. We also have integrated the wide range power supply, 24 volt AC-DC up to 240 volt AC-DC with minus 20% or plus 15%. So it starts at 19.2 volt and goes up to, I think, 32 volt. We have the same free programmable digital inputs and outputs as on the standard variant, and we have the free programmable analog output. You can use it as current output or as voltage output, and you can read out the isolation resistance between 10 k ohm and 1 mega ohm via the analog output. If you want to read out higher ranges, you have to use the digital interface Modbus TCP, or we have integrated in this variant the ISO data protocol, what's a serial ASCII protocol. You can record, for example, with a RS485 USB converter directly into the PC. We can make an update via the web server of the device, so if you have problems in the field or other problems, we can send you a special software, for example, or an update, and you can make the update via the web server, or the customer can do the update. It's a W variant, but we can just monitor in ambient temperatures between minus 25 degrees and 55 degrees, because if the temperature is outside this range, the influence on the measurement technology is too big, so that the accuracy, the uncertainty is much bigger. We have the UL certification, the Lloyd's Register certification, and we talked about it. We have the Modbus TCP interface in the isoHR685 as well. Typical applications are subsea applications, monitoring umbilical cables up to 10 gigaohm and up to 150 microfarad. That was the main requirement for developing this device, the 10 gigaohm and the 150 microfarad, because today in the most systems isoHR685 is used in the normal setting 150 microfarad. So the requirement was it has to work like isoHR685 but up to 10 gigaohm. Here you can see a typical umbilical cable. You can see hydraulics, power cables, communication cables, and in this power cables there are mostly 2 or more different systems. So another requirement was to monitor long parallel cables. That's not so easy with an AMP measurement principle, but the AMP measurement principle was necessary to monitor these systems because we have AC systems, we have DC systems, and we have mixed systems. So for example, one subsea want to goes to 1300 volt DC, but they also have 690 volt AC applications with switched power supplies in the subsea housings. So we have to choose the AMP principle and not just a normal DC principle. But please be careful. There is a difference of the DC principle between 265 and 365 because the variant 365 has a special internal filter characteristic which also can influence other 375 devices in other cables if the capacitance between the cables is high enough. So, and a main requirement was to see the trend of the cable and the system in a very, very early state. Here you have an example of the isograph which runs in our development department at the moment. So you see there the insulation resistance goes up from 2 gigaohm up to 10 gigaohm. Here there were 3 faults below 80 kiloohm. So that's what the customer wants to see, the insulation resistance in a very early state. What is the problem at monitoring long parallel cables? The problem is that between the cables, here you can see it, between the cables, that's a system galvanically isolated from this system, and between the system in the cable there are coupling capacitances. So, and if now a pulse goes from the one IMD through the coupling capacitance to the other IMD, the 2 IMDs will influence each other. That's the problem we had to solve. And what we have done is that we synchronize the pulses. We have a kind of synchronization, and this prevents the crosstalk between the systems. So I say both IMDs are pulsing to the same time, and then we do not have a crosstalk between the systems. That's the idea behind isoSync, which can be set up into the device. And if you monitor a system without isoSync, you see here a lot of influences through the AMP principle, and on this point we activate the isoSync principle, and then you have a flat line and no influences through another IMD. That was the functionality with the synchronization to monitor long parallel cables. It works to a kind of time synchronization, so we have no limitation to the number of the partitions. All devices where the synchronization is activated synchronizes their time between each other. And there are time slots, and each device can decide in his time slot if he wants to change the pulse or if he wants to make a coupling test or something else. So a device which measures in a system with a leakage capacitance with 100 microfarad can make another another AMP principle than a device which measures in a parallel system but just has to monitor 10 microfarad, for example, because there are time slots, and on this time slot each device can decide if it wants to change its pulse or not. This time synchronization can be done via BCOM. So the BCOM settings are necessary, for example, or the time synchronization can be done via NTP server. So you can set up an NTP server via the menu of the device. And then each device has the same time. You can also use the device in coupled systems with the isoNet functionality or with the F1, F2 functionality via the digital input. So if you have a coupled system with two generators, for example, and you have a potential free contact of the coupling switch, you can put it on a digital input of one device, and when the coupling switch is closed, the right device goes into the standby mode. But this works just to up to 690 volt AC and 1000 volt DC, because the internal semiconductors for decoupling are not specified for higher voltages. So every isoHR has an internal resistance of 50 mega ohm approximate value. So if you make isoNet system with the isoHR, you cannot accept values above 50 mega ohm. So please do not use isoHR685 for isoNet systems and expect giga ohm values. That's not possible, because each semiconductor switch has an internal resistance. So that's the isoNet functionality. I think most of you know this. Again, two generators with a coupling switch. So both devices are combined or connected via an Ethernet cable, and they are measuring one by another. But same specification, just for 690 volt AC and 1000 volt DC, because the internal decoupling switches are not specified for higher voltages. If you use higher voltages, for example 1300 volt DC, the semiconductors will be low ohmic and the one IMD will measure a fault through the other IMD. That's happening, but nothing will nothing will destroy it or something like this. isoNet works up to 20 devices, but please care to the 50 mega ohm of each device. So the isoHR is available as a display variant or as a sensor variant with the front panel 200. I think you should use this installation mode for new installations, but we also can connect the sensor variant on the backside of the FP200 to make the retrofit applications for isoHR685. Dimensions and everything is mentioned in the documentation. I will share this documentation next time with you. I think the launch will be end of November of the device. So here you can find a summary of the isoHR685. It can be used in systems for high ohmic isolation resistance monitoring up to 10 giga ohm. It can be used in AC systems, in pure DC systems, or in mixed systems, AC and DC systems. You have always mixed systems if you have AC power supply and subsea, for example, a switched power supply which makes DC or other AC voltages, and when this switched power supply is connected to the AC, you have a mixed system. So we can monitor every system. It's compliant to the product standard, means we can clearly trip also on symmetrical faults, and we can monitor systems up to 1000 volt AC and up to 1300 volt DC. With the IsoSync functionality, we can monitor long parallel cables without influencing one below the other, and the isoNet functionality is for 690 volt and 1000 volt also available. The market and typical applications for isoHR. we have developed it, or the main requirements come from oil and gas market for monitoring umbilical cables. They want to see the trend very, very early. The delivery time of a typical umbilical cable is up to 1 year, and it costs several millions depending on the length of the cable, but one subsea says that you have very fast costs above 50 million US dollars. So they want to see a very, very early trend to order new cables if it is necessary. And they want to see the isolation resistance while the subsea construction is raised up. So they put in the first cable and they see a drop from, for example, 7 gigaohm to 3 gigaohm. They put the next cable into all subsea. They put the next cable into the system and they see the drop from 3 gigaohm to 1 gigaohm and the next cable, and they see the drop from 1 gigaohm to 500 megaohm and so on. So they want to see how the system, the insulation resistance of the complete construction reacts while rising the complete construction. I think we have also good chances in retrofit applications because old devices often shows values bigger than 10 megaohm or bigger than 20 megaohm, but we have the requirement that they want to know if it's if they have 11 megaohm in their system or if they have 650 megaohm in their system. So I think also for old constructions we have good chances in the retrofit market. Another application is or our manufacturer of high voltage batteries, because mostly they want to measure the insulation resistance of the high voltage batteries, for example for electro vehicles or for high energy storages. They want to measure the insulation resistance in the production, and normally that you can't do this with a normal Fluke isolation reader, because the batteries have a very high voltage, for example 1000 volt or above. So you need a device which can measure the insulation resistance, very high ohmic insulations on live systems. Now I'm at the end of my presentation.